So we notice this is the 90 degrees. We know that that means these two angles together have to add to be 90. So I can find the missing angle by saying 90 minus 61. And I believe we would get 29, correct? That's 29 degrees. Now our next one, we remember that a straight line, its entire angle is 180. So whatever y is plus 23 should add to be 180. So we just say, let's take the 180 that we have and subtract 23. And we'd get 157 for y. And if you haven't taken the initial quizzes, do so too. They're a good review as well. And they count for points for your classwork grade. And sorry, this whole time I realized my screen was paused. Y'all couldn't see me writing, but so it seems like we're good with that. Now this next piece of material, I'll let people have time to write it down. We've got two questions. We want to find all the missing angle measures. Perfect, Jordan, correct. Now, as y'all wrote down this first one thing we want to remember is angles. If you've got lines crossing at a point, then angles opposite each other are equal. So y and 32 are equal, x and z are equal. So we really only have to find two things and we'll know all of them. I would say we already know y is 32 because they're across and equal. So if I could just find x, then I know z perfectly, or if I find z, I find y or x. With any of these, we could see that, well, y and x make up a 100-degree line, right? So 32 plus x has to be 180. So we could say that x is 180 minus 32, which should give us 148. And since we know x is 148, we automatically know z is 148. And if you ever want to, a good way to check your work is if you've got two lines intersecting, if you add up all the angles, you should get 360. If you ever wanted to verify. Now I'll zoom in here. Here, what we're focusing on is that we've got two parallel lines that are crossed by something else. And remember, for this next exam, just like before, you are allowed a single page of notes. So from 10.1, we did have those rules about like alternate interior angles, alternate exterior. I'd have those written down to make sure you can reference them. Correct, Jordan, for 1, 4, and 5. Give everybody one more minute to think of this on their own, and then we'll discuss. Correct, Jordan, for 2, 3, 6, 7. So at this one thing we notice is we definitely know opposite is equal, so angle 5 is 55. I can see that I could see this as a straight line and say angle 6 plus 55 has to be 180. So 180 minus 55 is 125, so angle 6 is 125. By definition, angle 7 is also 125 because they're across from each other. And now we need to find a way to bridge the gap. We need to be able to take information about this parallel line to the next parallel line. And that's where we could think of a few things. One is corresponding angles. Would y'all agree that angle 6 lies above its parallel line and to the right? Then by definition, the angle that's also above its parallel line on the other line and to the right is equal. So that would be angle 2. That's the idea of corresponding angles. Alternatively, alternating exterior angles. So this 125 at 7 is to the left and it's outside the parallel line, should equal its alternate angle that's opening to the right above its parallel line. And then once you have one of these, you get all the rest of them, but we could also say, oh, these are alternate interior, so they're equal. Once you know one, you know the ones across. And that's how we'd find those. So any questions from these angle problems from 10.1 that we could go over? Okay, if not, let's go on then to triangle problems. I'll give everybody a minute to attempt these two. Remember, all the angles in a triangle add up to 180. Correct one, perfect. Correct Jordan as well. Correct Jordan for the second. But 30 more seconds and then we'll talk about these two. So with this first one, I know 23 plus 68 plus the unknown has to be 180. So I know everything except the last one. So I could just set up in my calculator 180 minus 68 minus 23. That has to be the missing piece since they have to all add together to be that. And when you calculate that, I believe we would get 89. And you can always double check your work, add them all together. We should get 180. 23 plus 68 plus 89 is indeed 180. That means that we got our answer correct. Now for the next one, do we see this box here is actually implying to us an angle measure? That's telling us it's 90 degrees in code. So we'd want to translate that and realize, oh, this is 90. So I've got two of the three angles. So 180 minus 32 minus 90, and we would get 58 as our answer there. Now we also had some ideas about similar triangles. Remember, similar triangles are whenever the angles are exactly the same or the side lengths are constant multiples of each other. Sometimes they're going to be drawn embedded in each other, but we also saw examples in our notes and homework and quizzes where they're two separate triangles. This is just one possible way to visualize it. So see that you've got the bigger triangle and you have the smaller triangle. And then you want to figure out what's the side length of the bigger triangle. So I'll give everybody time to think about that. Remember, similar triangles are proportional in their side lengths. While I'll do that, I'm going to take attendance. You can think about this in a few ways. One way I like to do is compare like sides. So you ask yourself, which side do you know about in both triangles? And I think only the vertical one. We know in the big triangle it's 12. We know in the small triangle it's 4. And y'all see I'm picking the same location on the triangle, right? Both the uprights. So how would you get from the smaller number to the bigger number? What would I have to do multiplication-wise?
Multiply by 3.
Perfect, multiply by 3. So that makes me think if these are similar triangles, which they are because they're embedded, the little triangle, if you multiply it by 3, you get the big triangle. So I could just say, okay, well, I'm going to take the 3 side length, multiply that by 3, and I'll get the bigger side length of 9. That's one way you could think about the problem. Or you could also set up a ratio where you say the unknown side length over the known for the big triangle is equal in ratio to the other. But as I do this, I have to be careful. I use the horizontal side length here first and then the vertical. So I'd have to use little horizontal, little vertical. So I'd have to set it equal to 3 over 4. And then I can solve for the unknown. I could multiply both sides by 12, and I get my unknown is 3/4 times 12, which we could verify is also 9. So that's 2 ways to go about it. Now I also learned about the Pythagorean Theorem, which tells you in a right triangle, it does have to be a right triangle, how you can relate the side lengths. So if we had a right triangle A, B, C, we would remember and have on our formula sheet a squared plus b squared equals c squared. So take a minute to identify what you're solving for and substitute in the values. So if you're trying to remember, always the side across from the right angle is the C because it's the largest side length. So in this case, we have C and we have B. And we're wanting to find A. Is kind of how we think about it. And we do have to identify which pieces we have because it matters where in the equation you put things. So we would get the idea a squared that we don't know plus 16 squared equals 20 squared. Are we comfortable with that so far? Good. And then in our calculators, let's see, what is 16 squared? 256. 20 squared, I believe, is 400. So now we can solve for a squared. We're going to subtract 256 from both sides. And we get 144. And we might recognize that as 12 squared. If so, just say a is 12. If not, you could take the square root of both sides in your calculator. And we would get a is 12. Perfect. So yeah, so 144 is a squared. And then we do have to take the square root to get just to a. So that's the one trick in the Pythagorean theorem. The a squared is not your answer. You do have to take the square root. And in your calculators, y'all can look. You're either going to see a square root button, in which case you just do square root 144. And if you don't have that in your calculator, you can still get to the square root by typing in parentheses 144, close parentheses, exponent button. And this part's important, parentheses 1 divided by 2, close parentheses. That's the same thing as the square root. So any questions there why our A ended up being 12? Okay, so that covers, that's just a review. Of course, you also have your Canvas quizzes, right? And the homework and the notes, but those are just some additional practice problems from 10.2. Let's look at 10.3. And here, I didn't mean for these gaps to be here. That's just a problem in drawing. Just assume that it's a connected figure. Give everybody time to find the perimeters. Now we recall for perimeter, that's just distance around the edge. So we just add those all together. And do y'all agree with 14 for the first one? Now for the second one, we do have to do a little bit of detective work. It looks like we've been given this side length, this one, this one, this one, this one, this one, and this one. But I noticed that we haven't been given this side length. So we do need to find that first before we can find the perimeter. I'll give everybody a minute to try to find that on their own. Remember, there should be some symmetry. You know, the total height is 20, and you've already accommodated for 3 of it and 12 of it. So figure out what's the remaining piece there. And this is not necessarily drawn to scale. So if we've already accounted for 3 of the 20 and 12 of the 20, that accommodates for 15 of 20. So that would leave us with 5 there. And then if we say 20 plus 20 plus 12, 12, 5, 10, 3, 16, we should end up with a perimeter of 98. Now we did have one formula where the sum of the angles of a certain sided polygon could be found out by the formula n minus 2 times 180. I think that would be an important thing to have written down. So if we're looking at a 6-sided polygon, we could find the total sum. If you add up all of the angles together on the inside, that would be 6 minus 2 times 180, which should be 720. And we had some problems similar to this in the 10.3 homework. Now from 10.4 and 10.5, definitely on your note sheet, you'll want to make sure you have the area and circumference, volume, surface area formulas written down. They don't take up too much space. But take a moment to find the area of our figures here. And for this last one, do assume that there's symmetry. So this is a rectangle. Let's work on these on our own till about 10:40, and then we'll go through the solutions together. So as we work through, I think we'd notice our first one is a square. We know area is length times width. In this case, it's 5 times 5, so 25. Rectangle, length times width again, we'd get 50. For the triangle, remember it's 1/2 base times height. Here our base is 6 and the height is 8. So that should give us 24. And then for this one, we'll need to find the area separately. We first need to find the area here, the rectangle, and then add that to the area of the triangle, which is the attached figure. And by symmetry, we know that if the whole distance down here is 13, we know that 10 of it is the first portion from the rectangle. So this is 10. And if the whole piece is 13, would we agree the part that comes just from the triangle is then 3? So I could label this as 10, 3. And by symmetry, if the height is 6 on one side of the rectangle, it should also be 6 on the other side of the rectangle. So we could find that area by taking the area of the rectangle plus the area of the triangle. So that's 6 times 10, length times width for the rectangle, plus 1/2 base times height. And I believe when we do that, we should get 69. Now I think we have time for one more problem. Let's talk about area and circumference. Now, as we look at this figure, we need to focus on the fact that we've been given the diameter. And the diameter isn't often used. Most of our formulas have to do with radius. So I think I would personally just write in the radius immediately. The radius is half the diameter. Half of 12 is 6. Look at your area formula for a circle. It's pi r squared. And we know for our class we use 3.14, just so that we're all on the same rounding page. 6 squared. And that should be 113.04 is the area. And circumference is 2 pi r. Which I believe we should get about 37.68. Mostly concerned with volume and surface area. Remember, you are allowed, as usual, a single piece of paper as your note sheet, where you can write on the front, nothing's on the back. And from this chapter in particular, there's a lot of formulas. So as you're making your note sheet, go through section by section and make sure you have written down the important formulas so that you'll be able to answer these questions. So I'll give everybody a moment to attempt these on their own. The volume of a prism, remember, is length times width times height. The volume of a pyramid is 1/3 the area of the base times the height. So here you'll have to think about how do you find that area. And then for a cylinder, it is volume is pi r squared h, and then we have a different formula for surface area. And remember, if we're ever using pi in our class, round it to 3.14 so that we're all in the same rounding rules. So if y'all start finding the volumes, I'll write down the surface area formulas. And let's not do surface area for the pyramid. So for the cube, we see that we could think of this as the width, this is the length, and this is the height. So we have our volume is 5 times 4 times 3, or 60. And then for the surface area, you can think about the formula and definitely go through it if that helps. But you can also just think of the idea. We are finding the area of each of these separate rectangles that make up the outside, right? So to find the one I'm highlighting in pink, that's 3 times 4 is 12. And by congruence, right across from it is one with the same area. So it's like you have 2 times 3 times 4. That's the length and height. That's this one. And then you just do that for all of the 6 faces of the box. So also here, as we find the front and back face, we know the width is 5 while the height is 3. So this is a 15 area, but there's also a 15 area behind it. So there's 2 times that, 2 times width times height. And then finally, the final face of the box is kind of the top and the bottom of the box, which are formed by this rectangle, which has width 5 and length 4. So it has an area of 20. So there's an area of 20 here, an area of 20 here. That's what comes from this portion. So you can use the formula, but you can also think through and carefully get all the faces of the box. So our surface area is 2 times 3. Which I believe is 94. But let's check with the calculator. Yes. So any questions about volume or surface area of this cube? Make sense? Let's then turn our attention to the pyramid. Now the pyramid is always, the formula is not exact. You do have to think about it in context because it's always related to the area of the base, which is what this capital B represents. So that's something you have to separately calculate. And then we see the height of the pyramid is 6. So this base looks like a rectangle, width 3, length 4. So the area is then 3 times 4, or 12. So we would get 1/3 12 times 6. And I believe y'all agree with that to be 24. Good. Okay. Now for the cylinder, and remember, for your note sheet, you'll want to have all these formulas written down. A great way you could write out volume of cylinder, but that would take up a lot of space. Why not just draw the representative cylinder, radius, height, and have its formulas next to it? And that can be a really quick way to write it down and save space. I'm going to start writing out the 3.14, so I know to use that. The radius here is the distance halfway across the circle. Always make sure that if you're dealing with circles, you're given the radius, not the diameter. But here it is, the radius. And then we would square it, so 4 squared times 8. And we get the volume is 401.92. Yes. Lauren, is that enough upwards? Okay, thanks. Always happy to do that. And then I'll give everybody a moment to attempt the surface area on their own. Remember, the surface area is in pieces. First, it's finding the area of these 2 circles, and then it's finding the area of the material that wraps around the outside of the can. In each case, use pi for 3.14. And when we calculate this in our calculator, I believe we should get the surface area of 301.44, and I'm seeing that from some in the chat, so looks like we're all on the same page there. But remember, the formulas are not provided within the exam, so it is your responsibility to make a useful formula sheet so that you'll be able to answer these problems. So do make sure you do that before you take the exam. Now, the only thing from 10.7, remember, that's the one where we watched a lot of videos. It's somewhat complex to talk about rigorously, so instead we looked at some of the more interesting aspects of it, and then we only had one focus. And as you'll take the 10.7 quiz, you'll see it's only these type of questions. And remember, I did increase the attempt for that to be 4, since there's not that much help in the homework. And the key idea is things are topologically equivalent when they have the same amount of holes. Because in topology, we can think about stretching or shrinking. We can do anything to an object except cut it or glue it together. And we can't remove holes and we can't add holes. So we saw the video that said a coffee cup and a donut are topologically equivalent because you can imagine deforming it. But if we just say a cup and not a coffee cup, so here let's imagine this. Remember we talked about the difference between a well and a hole. Definitely a cup has an indentation, but in topology we could imagine that indentation being risen up to where you could get an object that has no hole. So if we're thinking about it, this has no holes, because if the cup had a hole, then the water wouldn't stay in, right? Whereas a donut has one hole. And there'll also be pictures so that you can visualize what it is. So in this case, we would say they are not. But if we make one improvement and instead of cup, we say coffee cup and donut, then they are. Does that distinction make sense? Because it's really the handle of the coffee cup that's making it topologically equivalent. Okay, give everybody a moment to think about the next two. Remember, this comes down to you thinking how many holes are in each object. Is it the same number of holes? So you can have 0 holes, 1, 2, 3, etc. And maybe in this case, let's not be too specific. Don't worry about that hole that technically I guess you can use to put air in, right? To the basketball. Ignore that. So in this case, we would think about under these constraints, a basketball has 0 holes. It's just a solid. And a pencil also has 0 holes. It's also a solid. Since they're in agreement, then these are topologically equivalent. Now our next one is a cube. So a cube is just a box where all the sides are equal. And whenever we say cube, it's implied that it's solid in nature, so all of this is filled in. And then they phrase it as an open top box. Take a moment to try to visualize that description. I think there's a few ways you could visualize it. You could imagine it as a box that the top is open. So the key idea is we'd imagine there's like a well there, but since only the top is open, do we agree it has a solid base? So is there a hole in the open top box, or is there just a well? Good. Yeah, just a well. Excellent. Now in the cube, is there a hole? So no hole here, no hole here because we're distinguishing between a well and a hole. So think about whether they would be topologically equivalent or not. Why don't we type Y for yes, N for no? Correct, Jordan? Correct, Morgan. Well done. Correct, Cleo. Well done. Great. So in this case, excellent, Gracie. That's correct. Good. So far I'm seeing people send in yes, and that's correct. Because they both have no holes, these are topologically equivalent. Okay. Now, it does take a bit of effort to translate this verbal description into the picture, and I didn't want there to be any confusion. So in the 10.7 quiz, it has the verbal description, and then under it for each problem, there are two pictures so that you can visualize exactly what's being discussed. So base your reasoning off of the pictures provided. This quizzes. Sometimes we're finding a perimeter of maybe an irregular figure, and we know the perimeter is just the distance all the way around. And as we look at this problem, we see that some of the sides have their distance given, but if we notice these sides, they would have to be counted as part of the perimeter, but their distance is not given in the figure. However, there's enough pieces of information that we can determine it. Would y'all agree that this distance in pink plus this distance in pink has to equal the total height? Because these are they're both the verticals. So it's like, in all, there is 5 meters available. And you see you've already used up 1 vertical meter. So let's type in the chat, what would be the remaining distance here for this remaining vertical distance? Perfect, 4. Very good. So that's how we'd find that's 4. So realize with these missing distances, they're either vertically or horizontally oriented, and that can help you figure out the problem. Great job, Cleo, as well. Now for the missing green side, it's a horizontal link, so I'm going to highlight the horizontals. And the way we read this is this whole distance here, the entire distance horizontally in the figure is 7 meters. But what do you already have accommodated for? 3 horizontal meters. So let's all type in our answer for this as well. Perfect, Jordan. This would be 7 minus 3, 4, because they have to add up together to be the same distance. So once you find that, you're now only 1 step away from finding the perimeter. You would add all these together. 5 plus 7 plus 1 plus 4 plus 4 plus 3. As you're adding these perimeters, I recommend you go in a pattern. I was just going in a clockwise direction to make sure I didn't miss anything. Okay, as you're adding them up. And I think we would get 24 as our perimeter for that. Great. Now I'm going to give everybody a moment to attempt this one on their own as well. I'm going to highlight as a hint the 2 missing side links that you'd have to find before you can calculate it. And think about whether they are vertical or horizontal. Focus in on all the vertical, see what the total amount is, how much you've already accounted for, so what must be left over. Same for horizontal. And let's take about 2 minutes to work on this on our own. While we're working on that, I'm going to take attendance. Now, as we're working through this one, if we look, the horizontal distance in this case is not given in one piece. I'm going to highlight all the horizontal distances in this figure in blue. So what we see here is, unlike our last problem, where one side was the total horizontal distance, do we see in this case, it's these two sides together that make up the total horizontal distance? So the total horizontal distance is 15, 3 plus 12. And what makes up the horizontal distance on the other side of the figure is this 9 and this unknown. So together, the 9 and the unknown have to be equal to 15, the 12 and the 3. We could subtract 9 from both sides, and we get the unknown must be 6. Oh, thank you, Jordan. I think it should now be visible. Sorry about that, everyone. So just to clarify that, since y'all couldn't see, right, this and this together make up the total horizontal distance, because all the horizontal distances at the top are known. But at the bottom, we only have the 9 and the unknown. So 9 plus our unknown amount must be equal to 15, which is the 3 plus 12. That gives us 6. Now for the vertical distance, in this case, we do have a single vertical distance, 10, on the far left. And on the other side of the figure, it's made up of these two pieces in green, the known 5 and the unknown here. And notice it does say this figure is not drawn to scale, so don't try to use the scale to help you determine, just use the ideas. 5 plus unknown equals 10. I think that tells us our unknown should be 5. Oh, but I missed something. Sorry about that, everyone. Just see, I missed this 2 here off to the side. It's also a vertical distance, so I do apologize for that error. 5 plus 2 is 7 out of the total 10 unknowns, so this should correctly be 3. Does that correction make sense? Okay, good. So then we add it all together. We take time to find all the sides. Remember, start somewhere and go in a pattern so that you don't miss anything. I'm going to start at the 3. You can start anywhere as long as you don't overcount or miss. Type this into your calculator. Okay, and if we could add those together, I would get 50, which I think that's what some people sent it on their calculator as well. Now, another thing that we had here was kind of this word problem where, based on how it was phrased, we do have to determine what we're looking at. So take a moment to read through and think about what affects the cost and the amount of fencing. What description, what one-word description? We will have to multiply by the 15 per foot, but how do we find out how much fencing we need in general? Does that seem like a perfect perimeter? Because perimeter is the outside amount, right? The fencing cares about the outside, not the amount enclosed. Excellent, Cleo, as well. Excellent, Jordan. And they've given us some hints about this. And as you're working through these problems, I think it's good to draw out a small picture. It doesn't take very long, and it's going to increase your accuracy. It's a rectangular field. And they said it's 20 feet long and 30 feet wide. And we know by symmetry, sides are directly across from each other and rectangles are the same. So this is also 20. This is also 30. And we know that the perimeter is the amount of fencing used. So the perimeter would be 30 plus 30 plus 20 plus 20, which is 100. So we have 100 feet of fencing used. And each single foot of fencing is $15. So to find the cost, you always take the price times the quantity. And we would get $1,500 as our fencing cost there. So just remember with the rectangular field, even though they just tell you 20 by 30, it's not just this, right? Because that's not a rectangle. Because of the symmetry of rectangles, they only have to tell you the length and the width, and then you can imply the other side lengths. Does that make sense? Good. Now we do have a bit of time remaining. I thought we'd go over some additional problems just to review this chapter 10. That way everybody could feel confident to take it as soon as they wish. You know, if you do have time before the holiday, while it's fresh in your mind, that might be a good idea, but you know your schedule best. Looking at our value here, we're saying find this missing value, but what do we recognize about it? It's part of a 90-degree right angle. So 56 plus the unknown equals 90. Reverse that and we get 90 minus 56 equals our unknown x. I believe that should give us 34. Great job to those who sent that in the chat. Take a time to attempt this next one. We know that anything that makes up a straight line adds up to 180. So this plus 35 equals 180. Reversing that, 180 minus 35 equals our unknown, which would give us 145. That's what we type in the box. Now here, let's change the problem to say, let's find A, B, and C. I'm going to give everybody a moment to attempt this on their own. Remember that A we can find similar to what we just did, but you will have to think about our knowledge about alternate interior angles, alternate exterior angles to find the remaining two values. Correct, Jordan? Correct. Well done. Give a minute for others to attempt on their own. If you have any answers that you'd like me to check, feel free to send them in the chat. Now, one of the things we want to keep in mind is we know that 105 plus A is 180. So if we subtract that, we'll get 75 as the unknown. And then we had a rule that said alternate, which these are on opposite sides, left and right of the cross line. Interior angles, both of them are inside the parallels, are equal. So we automatically know this is 75. And if we want, we can treat this as the straight line 75 plus C equals 180. We know C is 105. Or another way that you could think about it is corresponding angles are equal. What I mean by corresponding is, do we see 105 is to the left of the line and above its parallel line? C is exactly the same location. It's left of the line and above the parallel line.